I think in the next 10 years, we're going to see a battery in pretty much almost every device that we used to operate with an engine. And so it's really going to start to come down to which batteries are going to show the right economics, which are going to show the safest and the scalability, as well as things like charge time, which obviously we focus on at ZapBatt. But a battery, in our opinion, will become like a real asset for both companies and people in almost every device that they operate in over the next kind of 10 years.
Hello everyone, welcome back to another episode of Clean Techies, the podcast. This is episode 33, and today is our conversation with Charlie Welch, the CEO and founder and co-founder of ZapBatt. ZapBatt is a very exciting, interesting battery company that has a new battery chemistry paired with AI technology that really basically helps batteries last significantly longer. Up to 20 years is essentially what they're looking at, and they also charge faster. So very, really interesting tech. In today's conversation, we talked about their technology. We talked about a lot of things. I think my favorite part personally was the discussion around supply chain issues and the end use cases for these batteries. I think that was super fascinating to hear his perspective. He's got a really interesting background. So again, just generally very fascinating topic, super interesting technology. I think it will be a really big game changer for a lot of the eMobility space. So really, really great to have this conversation. Again, before we get into it, do want to make mention to our sponsors, NextWave Partners. NextWave are experts in talent acquisition and recruitment across the climate tech, renewables, and ESG spaces globally. So if your team is looking to grow, or maybe you personally are looking for a change in career, please consider reaching out to NextWave. You can do so at www.next-wavepartners.com, or you can reach out to one of their consultants directly by going to their LinkedIn page and finding someone in your space. So without any further delay, let's get into the show. All right, welcome to the show, Charlie. How are you doing today?
Good. How about yourself?
I am fine as frog hair. Looking forward to this episode. I was actually getting really pumped as I was preparing for this, kind of reading about the technology that you guys are working on. So I'm very, very keen to hear what we got. So let's start with, could you just give us a background on yourself, maybe introduce some of your kind of your history and your accomplishments, and then we'll go into there to the technology.
Yep. Yeah, absolutely. So I'll give the quick version. So obviously, Charlie, the co-founder and CEO at ZapBatt, how I got started in energy really kind of went back to college. Had a deep passion for solving problems in the energy space. Like my senior project was doing a solar powered aircraft that was powered by supercapacitors, and got to see the kind of fun dynamics of that. From there, I spent a lot of time at Northrop Grumman Aerospace, where I worked for quite a while in applied research in battery chemistry. Actually, my first job there, I should say, since the James Webb Space Telescope just launched, I was a materials engineer that got to work on a small part for the James Webb. So I was really proud to see that, successfully launch and stuff. But I spent most of my time in applied research and battery chemistry, where, I worked really closely with the military to try and work on some of their more exotic battery problems. They have some of the most extreme conditions, on and off this planet, and they work with, a whole variety of battery chemistries, some that have existed in the consumer space, some that haven't. And, my job was to build some of the hardware and software to see how these chemistries came alive, in the real world, or if they didn't, what were some of the shortcomings of some of these new miracle chemistries and stuff like that. How that led to ZapBatt is I, was working with all these chemistries that I was kind of curious why they never made it to kind of the consumer space, and realized sometimes the integration is a little more challenging than people give it credit for. And so that's why we've, taken a chemistry called lithium titanate, originally, developed for the Navy. They've been, using it for quite a while, and we've built some hardware and software to kind of enhance its capabilities to charge faster, to last longer, and then to be a safer solution to a lot of the standard battery chemistry out there. And then from a climate tech side, I started a project there where we built systems for the San Diego Zoo to help aid in wildlife conservation around the globe. So I'd built battery systems and different electric powered UAVs for them for projects such as polar bears up in the Arctic, down to South America. We just did a project up off the coast of Seattle with orcas, which was really cool. And so I'm kind of like to say, I like putting my money where my mouth is when it comes to, working on the kind of core tech, but then when it comes to tech making an impact on the world, I like to really get out there and do it for myself and see the impact it can have on both for our customers and then for like things like wildlife species and stuff like that. So kind of an eclectic background, but I think it's given a lot of insight into what the kind of future of batteries looks like, and then how to get them to exist in the real world.
Yeah, I think that's quite interesting. One thing I've noticed as kind of like a theme for a lot of people that have been on here is that a lot of the backgrounds have been, seemingly unrelated to what they end up in, or maybe kind of loosely tied. But I think it's those weak ties and those, you know, unexpected conjunctions that end up making something really interesting. So I was actually kind of curious a little bit about your education background. How did that end up leading into batteries? Was that because your aerospace experience just led to you working where you did, and then into the technology that you worked on?
Yeah, so the aerospace side I kind of leaned toward was electric aircraft, and so Northrop hired me to work on some of the research I'd done at my university to continue it into this kind of like more electrified aircraft space. And then they kind of threw me in the deep end of the battery world, and I just learned as fast as I could. Just kind of carry over what I could to say, this is what it's going to take to make an electric aircraft possible, and then this is how we need to bring those batteries alive.
Mm. I'm kind of curious, like with the R&D process, you said that there's a lot of just kind of miracle testing, trying to pair different things together. Is there a specific way or method that you go about that? Because I'm assuming, given your knowledge of certain properties, you probably say hypothetically, maybe these two things together might make something interesting. Like, how does that work? How many times do things blow up? Like, I'm just always curious to understand how that like plays out. Because to me, I feel like R&D is oftentimes like under talked about, because it's not super exciting until you find something cool, right? There's a ton of boring things until you eventually get a breakthrough. So I'm just kind of curious if you could speak about that.
Yeah, especially with batteries, it's like kind of like watching paint dry, setting batteries up on a test stand. So it's a good question. The way we looked at it is that a lot of folks have kind of come up with new battery solutions that exist on a lab bench, where they're like, we have this new chemistry, we have this new formulation, and we're getting these great properties out of it. But a lot of times it's in super controlled conditions. So it's in a super controlled temperature environment, cycle environment, power environment, and then there's a lot of these other constraints. And so we had to take like a methodical, let's simulate all these 20 applications and see what this chemistry does in every different condition. Because we'd see a lot of times that there may be a really good energy density in this one condition, but in some conditions you could get 50% or less of that. And so that's where a lot of the bridge came in, is if a plane or something is going to depend on exactly how that battery performs, we had to go through kind of the methodical process of what's every condition this chemistry is going to see, and where does it lose and gain energy density, where does it lose and gain power, what happens when there is, as you said, like a thermal event, does it propagate, does it does it self get rid of itself? And it's a tough process, and that's, I think, where working in the military gave a lot of discipline there, because they don't have a lot of room for failure, if not any room for failure. And so we had to take a very stringent approach to say, miracle chemistries in theory are great if they work, but they have to work in every condition for them to work, which is a tough space to be in.
No, I think that is an interesting observation. I've never thought about that. I think they're probably just trying to drive, I mean, maybe not drive headlines, but drive like something that's really flashy, right? And they can do that by having a controlled environment. So maybe the incentives are not quite aligned. But I guess one other thing I'm curious about, this has come up, I've heard some people talking about this, is sometimes the military obviously is talked about as being a massive emitter of carbon globally. I'm curious, like, what was it like working with them? Was most of the technology focused on just kind of the use cases, or was it really, do they talk a lot about climate change and those type of things there?
Yeah, they do. I forget who came out recently and said, but they've publicly stated that climate change is one of the top priorities for them, in the next 2 decades. And what we saw was an investment in the infrastructure, the footprint that it takes, like for things like infrastructure storage, obviously for things like ships having Some of them benefit from having nuclear reactors on board, which is great, but they are taking a very active approach, I think, at looking at the technologies that could significantly impact their carbon footprint. I know that they were a big investor in the early greener aviation fuels that came out as well. But the military is a very big, very slow moving organization, as we all know. So I think it's something they're actively looking at, but like any group, it's going to take them a while, I think, to get all these solutions implemented.
Yeah, I guess I just find it extremely interesting having very, top military officials saying how important the issue of climate change is and how much of a threat it is. I think that, there's obviously, if you know my background at all, I grew up in an area where there wasn't a lot of people who believed in climate change. So like I had to find my way into this. And I think that having different people with different knowledge levels kind of start to talk about these things is extremely important, because some people are only going to trust it coming from a certain person, right? So I think it's always interesting to see that. Okay, so wanted to move on a little bit more to kind of just batteries in general. I know we've had a lot of people on here. I don't think we've really gotten an overview of some of the challenges that batteries face. So could you maybe walk us through, I guess first thing I want to know is, what is the anticipated demand for batteries as we are trying to electrify the grid and just kind of everything we do? Do you have any data points on what's expected there? Whether it's North American data or just globally.
Yeah, so from most outlets like Bloomberg or similar, they're expecting like a 10x increase in battery demand to come over the next decade by 2030. And that's from everything like infrastructure, as we switch to renewables for things like infrastructure. Obviously, things like localized storage is going to have to become more and more prevalent, since you can't throttle certain types of renewable power. And then obviously the increase in automotive EVs, as well as like California, I can't remember the date off the top of my head, but things like agricultural equipment, like leaf blowers and stuff, have to become all electric. And so I think in the next 10 years, we're going to see a battery in pretty much almost every device that we used to operate with an engine. And so it's really going to start to come down to which batteries are going to show the right economics, which are going to show the safest and the scalability, as well as things like charge time, which obviously we focus on at ZapBatt. But a battery, in our opinion, will become like a real asset for both companies and people in almost every device that they operate in over the next kind of 10 years.
Got it. Okay, and then so when people are developing batteries, could you maybe list out, like, I think you mentioned a few of them already, what are typically the main, I guess you could say, buckets of consideration when developing batteries for specific use cases? Like, what are the things that they need to be considerate of?
Yeah, so for a while, the two markets that really drove battery technology were cell phones and electric vehicles, obviously, because they had like the biggest impact on a consumer for a while. So they kind of had their hand on the requirements of what they wanted. And so for those industries, they're still driving things like energy density, which is, how long can your cell phone battery last? Especially with the cell phone market's unique, obviously, because they have almost, their power demand is going up and up and up as they're getting slightly better and better batteries. Like my iPhone today doesn't last necessarily way longer than my old iPhone, because my chip's getting faster, and I can stream video and 5G. So they're looking for things like lithium silicon or other, new chemistries where they can try and pack more and more energy into these batteries. And they have the benefit of not being in crazy power environments. Like your cell phone's not necessarily having these huge power fluctuations that are going in and out. So their chemistry can be designed to act in a much more stable condition. EVs are much more difficult, obviously, because, like people who drive cars, some people drive, very, very gingerly, and then other people drive it like they stole it. So there's a whole variety of power demand, which is why, EVs have been very challenging to adapt new battery chemistries, because like I was saying earlier, sometimes you don't really know how a chemistry works until it's been around for 10 years, because you need to see all these use cases in power, temperature, the dynamics of how, thousands of cells in a string work together. Those will take a lot of time to put together. So, that's where I think there's all these other industries where they've been waiting for kind of the bleed off of those technologies. Like they don't drive necessarily the battery technology, they wait for good battery technology to come out to like for e-bikes, for example. And so that's where I think we'll start to see new chemistries expand, is they'll find niches in some of these other applications where they may not maybe care about the ultimate energy density, but they want that thing to charge, in a few minutes, or they want it to last 25 years or other, there's more different requirements. So I still think cell phones and cars will kind of push along, and then we'll start to see other industries that have to electrify ask for, more exotic requirements from different battery types.
Yeah, that makes sense. I think, I guess to somebody who's not technical at all, like I never, I guess, really thought about the major differences between the use cases. So that's interesting to see that there will be, with more demand for all types of batteries, there'll be some more use cases that I'm sure they can, lump a few of them into similar types of categories. But I guess a couple other things I'm curious about. What are some of you probably spend a lot more time in the space, or maybe people tweeting you. What are some of the concerns people typically raise with the increased usage of batteries? I know I've heard some people say there's very limited resources, for example, for lithium, and how China, for example, controls most or has a large deposits of lithium. I'm just kind of curious, like, what are some of the biggest concerns that people raise, and maybe the rebuttals to those concerns?
Yeah, that's a great question. So what I think is interesting, to kind of start to that, is I think a big concern is that batteries are seen as like carbon neutral themselves, but a lot of times, it takes a lot of energy to make a battery. And so we have to find, there's a lot of concern around what happens when there's batteries and everything, but we have to replace those batteries, in a periodic time frame. So it's not like producing batteries goes to a net zero, and then the control of materials to remake batteries or recycle them. Some companies have come out with some really amazing results around, opening up a cell and then taking the raw materials and producing it into a new anode and cathode, which I think is great. But I still think there's a lot of concern of electrification is fantastic and it is the way of the future, but we still need to set up like what the supply chain is going to look like and how we're going to refresh. Once we have batteries and everything, there has to be a cycle of either having to replace them or having batteries that last long enough, to make them economical. Like for people who invest in a battery for their house, those batteries are pretty expensive, for a home. And if they have to replace them every 5 to 8 years, that's a pretty significant investment on their part, which can be, can cause hesitation. It's kind of similar to what solar went through in the very beginning. Is everyone loved it, but for some folks, it's a big capital investment, kind of right up front, and it's hard to see sometimes a long-term benefit.
Okay, that makes sense. Maybe one thing I wanted to talk a little bit, I think this is obviously going to be your expertise, is I've heard people mention that fast charging is, wears batteries down. So could you maybe talk a little bit, and we can start going into your technology specifically if you want, but I'm just kind of curious to understand maybe the principles of what is the best thing for a battery. Typically, can it be designed to be fast charged and be better for the battery? Could you just talk about all those things? You can get technical if you like.
Yeah, so fast charging for typical chemistries does degrade the battery. And so that's mainly because when you're going after energy density and power density are often an opposite curve. Like the higher the energy density, typically the lower the power density, which means like my cell phone isn't designed to charge in 5 minutes per se. It's designed to last as long as it can and then charge over a few hours. And so fast charging does come down to the electrochemical level at first, which is where lithium titanate really shines, is that the technical part of it is that it has a more active electrode surface area that allows charges to move a lot easier and a lot quicker than a standard chemistry. So you can charge a lithium titanate battery in under 15 minutes and still get 15,000 cycles out of it because it's designed to do so. The second piece is you also need the plumbing that can do the fast charging, which is the kind of second really challenging piece. It's like, if I have a miracle bucket of water, I also need an amazing faucet that's gonna be able to do everything really seamlessly for me as like a user. And that's where I think things like cars necessarily haven't broken into fast charging, because to charge a lot of companies came out saying we're going to charge a car in 5 minutes. And my question to them was always like, that's a really big charger. You're talking about 1 million watts maybe plus to
Mm-hmm.
charge, a 250 kilowatt hour car in 5 minutes,
Mm-hmm.
which comes into huge questions. So I think things like e-bikes, all these industries that we're targeting as ZapBatt will benefit tremendously from fast charging. And then lithium titanate itself is kind of the powerhouse that can handle it from the electrochemical standpoint. And then the software and all the other, plumbing is what needs to kind of come into line to make sure that it's as easy for me as a consumer to just, plus minus, it does its thing in a few minutes, and then, I'm done. I don't want to do any extra effort than that.
Okay, got it. So there's a couple of different considerations there. Okay, that makes sense. All right, and then I guess getting into what you're doing with ZapBatt, could you maybe just kind of give us some of the technical details in terms of like why ZapBatt, their batteries, why your batteries are really applicable for this situation? I know there's a mention on your website, you guys talk about AI being involved with these batteries. So kind of just give us the rundown and explain to us kind of your market here.
Yeah, so what we've done is build basically a hardware software combination for lithium titanate that allows it to be a one-for-one swap of any lithium ion chemistry. So one of the unique characteristics about different battery chemistries is that they have different voltage windows. Sometimes that can be very unique. And so a lot of times the standard chipsets out on the market won't work with a lot of battery chemistries. So for companies to adopt them, they've got to do all this groundwork of developing a whole suite of custom electronics to get all the benefits of a new chemistry, which was kind of like what we used to do at Northrop. And so what we've done is both make a hardware system that allows lithium titanate to be a one-for-one swap. And then we're working on basically an AI system that, since lithium titanate can move energy so quickly and so efficiently, it essentially allows it to become more efficient over time because it'll learn how the battery is being used and then slightly adjust its kind of own internal performance to say, hey, maybe my e-bike in Sweden should operate a little bit differently than my e-bike in LA because of just the unique properties around how the each environment wants to use it. And so what we've shown is as a system, the lithium titanate system is much more efficient overall than a standard battery chemistry because of all its efficiency in all these different environments. So for example, for e-bikes again, because we can charge so quickly, we can absorb more power from things like regenerative braking. And so typically for e-bikes, they would see around 1 to 2% of their ride returned from regenerative braking because they'd have to down convert the power to go back into the battery, whereas we can take 100% of it. And so we've seen an increase of 15 to 20% of your ride regenerated from braking, since it's like showing us that there's all these opportunities to regenerate energy from.
Okay, interesting. That's quite fascinating, to be honest. I've always loved the Tesla's auto braking that you don't have to actually press the brakes on. Just thinking of that. What about, so with what you guys are doing, are you just basically selling the batteries, the small cells to whatever size, or are you making deals with partners to create specifically packaged batteries for their use cases? I'm just kind of curious about the business model, and I don't know if this would be the best time to talk about it, but the return on investment using a ZapBatt battery compared to a traditional or existing battery solution.
So basically the simple version is like we sell batteries to companies where, for example, for an e-bike fleet, we would sell them basically a fleet of batteries that would go into their e-bikes that they can choose as like swappable or non-swappable. And we have kind of standard sizes of each system that comes with the cells, the electronics, and then all they have to know is really the plus minus at the end. We put together like a fully packaged system. And for their ROI, we've targeted industries where, it's about uptime and they're designing their economics around a battery. So for micromobility, so for shared electric bikes and scooters, the economics of the labor it takes to, take a battery that charges for 5 to 7 hours back to a warehouse, plug it in, have it sit there, take it back out. When that changes to 15 minutes, we've seen using their operational model between a 25 and 45% decrease in their operational cost. Because they don't have these blocks of time that they have to spend, even with swappable, around a battery. The labor cost drops significantly. And then because of that, they also have a reduction of safety stocks. They don't need as many extra batteries or extra vehicles. They can do things like in-field charging, where as opposed to having to take it back to the warehouse, you can kind of head around and top off all the systems in 5 to 10 minutes. So it's kind of a rethink of how their operations can work, where the battery now is more of a has more range to do more for them because it can charge so quickly and while not degrading its cycle life.
Okay, interesting. And then I guess on to the next thing would be the battery lifespan. So could you maybe talk about what is the typical lifespan of your batteries for your estimates, and compared to existing typical batteries? Like, let's keep on the topic of e-bikes or scooters.
So they typically see in around a 12 to 24 month lifespan. So right around 1,000 cycles to 1,500 cycles based on the environment they're in. And granted, everyone rides e-bikes, pretty sporty, I guess you could say. The other thing interesting about cycle life is in the battery space, it's kind of a unique topic because everyone compares their cycle life to themselves, where they're like, our battery gets 5,000 cycles or whatever it might be, if you charge it how we want it. And so it's oftentimes not compared to like a static metric where we say we can get 15,000 cycles at a fast charge rate. And so for a lot of these chemistries, if you said, well, you now have to compete by charging in 15 minutes, now their cycle life could drop by 50% or more. And so at a slow charging rate, typically 1,000 to 2,000 cycles is what we're seeing in the micromobility space at best. And then what we're seeing out of our chemistry is around 15,000 cycles out of the fast charging as well.
Oh, wow. That's a pretty big factor of increase. One thing I'm curious about is, given the construction of these batteries, what is the difference in size, and does it actually matter, the difference in the size of the batteries compared to conventional?
Yeah, it doesn't matter that much. So energy density also has like a certain scale. So we're slightly less energy dense day zero at the electrochemical level, but we're about 10 to 15% less energy dense than the typical kind of lithium ion competitor. But for an e-bike, that's a pretty negligible size comparison. You're talking about maybe an 8-pound battery going to a 9-pound battery, or a pound and a half, which for a total weight of a bike is maybe a few percent at most. So in our opinion, it's super negligible. Like, I would rather have all the great capabilities than save 1 pound on my bike. But that's why things like cell phones and other stuff, like energy density for them is like, they can't make your pocket much bigger, and all that.
Yeah, exactly. No, that's what I was wondering, because I was curious about the, because it has so many charges, like, does it actually need to be the same exact use in every situation, or can it just be recharged? So that's interesting. And again, like, we need to focus on the specific use case, right? Because otherwise you can't make one battery that can do everything. I'd be curious to see, as the AI, as you guys get that kind of figured out, how it will be able to maybe make it more of a kind of like you said, it will learn, so it can become more versatile in terms of when it's used in different situations. But one thing I'm curious, and you mentioned this a little bit, do you guys have any current plans for cradle to cradle kind of end use case of these batteries? Like, what are you thinking? I know that's kind of down the road a bit, especially as you're starting here, but I'm just kind of curious if you guys have thought about other uses, or maybe what other companies are doing in general, just to kind of understand some of these possible recycling and circular economy type ideas.
Yeah, definitely. The infrastructure space is definitely somewhere we're looking at and have a few pilots in, where at 15,000 cycles, in theory, if you have a cycle a day, that's like 45 years, which would be both great for climate impact, but then also like the economics around investing in a battery. And so we're trying to look for that secondary space where the fast charging is great because it can be that heavy lifter, but
I lost you. I lost your sound.
Oh.
Yeah, I lost your sound for a second there, but we're good.
Oh, my back.
Yep.
Okay. Yeah. So at a very long cycle life, the economics become super attractive, where you're investing in a battery amortized over a really long period of time. That's both great for recycling, use of materials, carbon footprint, and then it's really good for your cost per cycle. And so that's where I've always thought it's kind of strange we are so hyper focused on dollar per kilowatt hour, because it assumes that you're only using the battery once. Like it's saying, I get this dollar per kilowatt hour on day zero, but your battery is functioning over X period of time. And so a more accurate conversation I feel like should shift is dollar per kilowatt hour lifetime, which is technically when I pay, say I pay $1,000 for a battery, I'm paying for, imagine like a big block of energy this battery can move over its lifetime. And so instead of saying I'm paying $500 per kilowatt hour day zero, it's kind of like I'm paying 30 cents per kilowatt hour over its lifetime, when I'd rather be paying 10 cents per kilowatt hour over its lifetime. So,
Okay.
So yeah, I think the infrastructure space is definitely somewhere we're looking to go as well.
Interesting. I guess I was kind of curious. I don't know if you have any stats on this, but especially if these batteries can last so much longer than the typical lifespan of a lot of these, what do you think will be saved in terms of like, if it's even, if you can even like compute it, like, right? I don't know which, if you have the stats for it, but how much materials would be saved from using longer lifespan batteries like this?
A ton. Yeah, a lot. Because it's obviously not just the lithium, it's all the other things that go into making a cell, which for other chemistries, can be also pretty difficult materials to get. But, for lithium titanate, maximizing the lifespan of the raw material itself, among the other things, really has a huge cost savings, especially on the environmental impact side.
Mm-hmm. And then I guess along that lines, do you have any insight in terms of the availability of these resources? I know, like, I think I mentioned it earlier, a lot of people are concerned that we're going to run out of these natural materials to build these batteries. Do you have any like insight or just thoughts in general on that argument?
Yeah, I think for lithium, we're fine. Like there's a lot of lithium in the world. And I think it's just that like now we're looking at it, but there is plenty of lithium to feed, battery supply chain for quite a long time, especially if recycling comes online. I do think that looking at some of the more challenging materials to get, like cobalt, we've seen folks talk about cobalt-free, batteries will be a little bit of a challenge because a lot of times they come in very difficult environments to get. And I don't think, sometimes mining those materials is pretty harsh. And so I think on the lithium front, we're fine. But I think chemistries that are simpler, like lithium titanate, are going to shine because it doesn't have such a complex supply chain of getting, 6 different metals or whatever it might be to create one battery.
Could you talk a little bit more about that? I'm always very curious to understand like where the resources come from with this specific battery. Where are a lot of these resources located around the world? And could you maybe talk about that simplified process?
Yeah, I'm not as familiar about the titanium part of it. Lithium, as we're all kind of familiar, like you said, comes from China. There's big deposits in Chile and a few other spots. But titanium, I'd have to get back to you on that. I can't remember exactly where a lot of the big titanium sourcing for the raw materials are, but that's a good question. I can follow up with you on that one.
Yeah, I just find it interesting because I think that, obviously we can't account for specific innovations that will happen. I've referenced this several times on the podcast. People who've listened several times get annoyed, but the invention of the color TV, right? Like there was a specific resource that was very limited, and they said, "Oh, we're going to run out of this if we don't if we don't stop." But we came up with a new technology, and we still have color TV, thankfully. So I think that my anticipation is that something like that will happen, where there'll be other breakthroughs that we'll be able to kind of shift away and still preserve resources. So I'm not too worried, but I also have a lot of faith in humanity.
Yeah.
In terms of, I guess, maybe just kind of looking at the macro with energy electrification, or whether it's battery specific or if it has to do with eMobility, what are some of the things that you're looking forward to in terms of the macro? Like what are things you think are going to happen in the near future? Any predictions you have? I'm always curious to hear your insight given you're kind of immersed in this industry.
Yeah, I'm mostly excited about the change to things like transportation with the emergence of micromobility. I was just talking about this with one of our coworkers today, but so for example, in LA, it's like if I want to get from my city, Hermosa Beach, to Venice with a car, it's not very far, but it's a very difficult task. So I got to go out to the freeway, go up, back over, look for parking, everything in that. But if I take my e-bike down to the Strand along the beach and ride straight there, it's almost the same amount of time. and it's like an awesome, an awesome ride. And so
Mhm.
I'm really excited to see how cities and similarly are going to kind of engage in this like rethinking of how we can organize based on electrification for industries like transportation. And then, I think that's going to spark a lot of innovative ideas. Like it's just going to open up people to the possibility of how they can get around and this and that. We've obviously seen a million and one, ways to do that with things like or vertical electric takeoff, helicopters and stuff like that. But yeah, I think transportation is going to change a lot. I think in the next kind of 15 years, and I think I'm very excited to see kind of what happens there.
Yeah, I share the sentiment. I think it's going to be interesting. I'm always arguing with people back in Wisconsin about transportation. Obviously, like I think that we look at a lot of times people complain about the government subsidies into kind of changing the situation, but when you look at it, GM and all those companies that kind of built cars and built the nation around personal ownership of vehicles, I think it would have been very different if we had focused differently, right? Now I'm in Lisbon,
Mm-hmm.
getting to see all the amazing different modes of transportation. It's really cool. So I'm excited too. I think it'll be interesting to see, especially how people try to anticipate movement and change of where people live and all those things, because obviously it's all dictated about the route, right? Where do I need to get to? Where do people need to get to and from? So I'm curious to go. I don't know how much we can talk about this point with batteries and specifically this, but what do you see as the role of data and AI and IoT, generally speaking, within the battery sector? And if you can speak anything more to what you are doing with AI in your batteries.
Mm-hmm. I think it's a great question. I think that's been one of the most important spaces, because what we learned a lot with doing so much R&D in kind of the battery space is a lot of people treat batteries to a certain extent almost like a black box, where they're like, it starts here and ends here, and then that's how much energy I get. But there's a lot going on there, and it's kind of always changing day to day, cycle to cycle, in a whole variety of ways. And so I think as we learn more about the actual core parts of how battery functions, the more we're going to see how we've been using and misusing batteries and all these different applications. It's like we use the analogy of like a marathon runner, where if they knew at any point in time how much hydration, how much this, like all these factors about their race could be understood, they'd probably run a lot more efficiently. But a lot of times they just, some people do obviously, but some people don't approach it that way. And so
Yeah.
that's where we've tried to, put so much effort into the software side and are continuing to do so. Is the more we like to say, we want our batteries to teach us how to make them better, as opposed to us trying to say, this is a battery, it starts here, it ends here, go have fun. There's so much more going on, especially when you have packs, you have hundreds, if not thousands of batteries in the system that are all doing heavy lifting and all that kind of stuff. And I know a lot of companies have been looking at that, but I think to your point, it's going to be a super critical piece over the next kind of decade or so, is to bring in that IoT of, where's my energy going and why, and how can I make that better?
Yeah, I think that's an interesting, concept of the idea of trying to be open, right? I think what I have noticed is that the whole reason it takes a long time to typically shift is because they're all, or the majority of the people who work in those industries are kind of ingrained in like, here's how it's done. And the percentage of people who are innovating and thinking like, how can we smash these two seemingly unrelated things together and make something better? So that's quite interesting approach. And I guess I'd be curious to see how AI helps every industry with that in the future if people become open to it.
Yeah, I like to think that we or I like to say sometimes, like, I feel like we're still kind of like energy infants, like we got, in all honesty, like super lucky that petrochemical fuel just comes out of the ground. And we've kind of grown up with the mindset of like, look how much energy is in this amazing thing that comes out of the ground and we can refine it, all this stuff. But, like humans, for example, we don't eat all of our food for the day for breakfast and then wait till we're dead to almost eat again. Like we've come to understand how we use energy so well that, day by day, we're making every step we take more efficient for like running a race or this or that. And so I think understanding our energy over the next period of time is going to make us much more advanced into like how we use it, how to make it more efficient. How does adding renewables to the grid, need to function among everything. And it's gonna be a challenge, but I think it's, we're starting to mimic how we work to a certain extent.
Yeah, that makes a lot of sense. I think if we just keep getting, incremental improvements, 1% every day equals a lot every year, right? So,
Right.
I guess maybe to shift it a little bit, I'm curious what your thoughts are, and kind of combining with your experience on education of getting people into the sector, right? I think from my perspective, I haven't noticed that there's any per se shortage of people getting into battery technology, but I'm curious if you have any specific insight as to, um, do you feel like there's enough people going into batteries? Are universities doing enough to try to keep people on top of things? What has your experience been like? Just kind of anything in that realm. I'd be curious to understand.
Yeah, I think that a lot of the education, in my opinion, needs to go towards batteries as a idea of a system, and not the idea of like a battery just as kind of a standalone thing that turns on and turns off. Like, if I'll go back to my university and talk about this with different senior project groups, we'll talk about the idea of C rate, which is like a metric of certain batteries where it's like the idea when it comes to energy density and C rate of, let's say I have a battery that has like very, very good energy density, but only at very low C rates. It'd be like saying I have a car that can go 1,000 miles, but you can only go 10 miles an hour. And so a lot of the dynamics around how a battery operates in a system is, I feel like, going to be more of the future challenges and less of like the, we need to try and cram as many electrons as possible into this tiny bucket. Because from the research side, there's a pretty good path forward into understanding where the kind of limit of certain batteries lies. And I think a lot of the future work that needs to be educated is, how do we maximize that? Like, how does the software work with that? How does the software tell us how a battery's doing? How can a battery improve itself over time? How can, how does a user care about a battery? Like what is a battery doing for a business? And that's where I feel like the education piece is lacking a little bit. Because we kind of grew up with like the AA mindset of like, I plug it into the toy and it goes, no, when it's done, I pull it out of the toy. But with lithium chemistries, there's so much more going on. And a lot of the details are kind of in the plumbing and what's happening, which can be some of the biggest pain points for what it takes to make a battery powered system.
Interesting. And then, so you said you are pretty involved with helping, like, kind of chat with your former university and talking with them to keep people up to date.
Yeah, absolutely. I love getting to that kind of stuff. There's just, especially in aerospace, there's like 1,000,001 fun stories. When talking about batteries, like, militaries put batteries in so many crazy fun things. Like if you look at Voyager 1 and 2, the first satellites we sent into deep space, like they're still powered. And they've been powered for, almost 60 years, which they're using a radioisotope generator. But a lot of the early systems use these like crazy weird batteries. And so it's fun to kind of show people where there's this weird history of, like spacecraft have batteries in them. The Mars rover, the Ingenuity helicopter was battery powered. So it's fun to get to kind of show people where, if you can do cool stuff with batteries, you can now build all these really cool things that are, the applications are what's fun.
Are there any specific pairings that might seem unusual in terms of the degrees that people go into if they're looking to get into the battery space? Would you recommend like pairing any specific major and minor?
Definitely. I think, the material side is always going to have a need, since we're trying to look at new chemistries, materials, all that kind of stuff. Like a materials engineer and electrical engineer is like the perfect threat of, knowing what's happening deep inside the battery, and then knowing how it's trying to move the energy around and kind of what the whole circuit looks like. And then obviously the computer science side of, trying to build software that can help us understand how a battery works and stuff like that.
Interesting. I guess one thing we didn't talk about, which I think we should probably be interesting. What has the process been like of kind of getting ZapBatt off the ground? Obviously you came up with the idea. How did you get funding? Like, I'm kind of curious to understand that side of things, because I know that at least right now, there seems to be a lot of money going into climate tech. I'm not sure if it was that way 2-3 years ago. I'd be curious to hear your kind of background there.
Yeah, it's a fun story. So as you probably can imagine, as people told you, starting companies is, a very, very big challenge, especially in the battery space, since, a lot of folks, as we kind of talked about in the beginning, have talked about miracle batteries and this and that, and we're kind of always competing with that idea that some miracle technology is going to come, save the day. What we've done is take a very pragmatic approach where, through my background, I've worked with 24 different chemistries and kind of said, I see a chemistry that's been overlooked, and I think if we can enhance it, we can take something that's proven and then solve a problem in several industries, as opposed to trying to invent something brand new. And so for starting ZapBatt, we've tried to say that we know how the technology works, we know it's proven, and now we're looking at how does this battery technology affect a market for things like we talked about in e-bikes and scooters, where even if a miracle battery did come out, doesn't necessarily solve the problem. And a lot of times the answer is not really. It can maybe influence it a little bit, but you can solve the problem if you can look at the battery issue a little bit more creatively. And so we've done fairly well there, since we've kind of targeted the industries where their economics are built around a battery. And then so far, we've been angel funded. We have a really, really great group of investors. And then we'll be, once our kind of more production samples are released this year, then we'll be going out to kind of raise more money as we target some of these bigger industries.
Interesting. Yeah, that's a cool story. I think it's always interesting to see the evolution of these things, because as you know, no company is easy to start. So especially a hardware company, which we're going to need a lot of in the climate tech space to solve these problems. I always find it interesting when companies aren't open to investing in hardware companies. I do understand the risk is high, but at the same time, like if you can get it right, the reward is also pretty high. Maybe one last thing I didn't ask about is, do you have any perspectives or thoughts, generally speaking, on the role of regulation in the battery space, whether it is for smaller use cases like eMobility, or if it's on the larger side for EVs? I guess I'm just kind of curious to hear your perspective, especially having worked for the military, and it sounds like you've worked a little bit with people in academia. I'm just kind of curious to hear your thoughts there.
So I really think we should invest in regulation around disposal. I think that's somewhere that's been kind of a miss. Is a lot of industries have gotten used to buying an electric vehicle that then can be disposed pretty cheaply. And like we were talking about earlier, I think it's kind of a shame to have a battery that only lasts, it's kind of like single-use fashion to a certain extent. Like, we're putting all the time and energy into creating a battery. I think it should either last long enough to make it impactful on both its carbon footprint, or if you do have to dispose of it, it should be disposed of very responsibly and very strictly, which I think has been kind of a loose regulation right now of how are we disposing of all these semi-hazardous, semi-flammable, batteries. And I think that's somewhere that could step in. And then on the infrastructure side as well, I think I would love to see people look at the total lifetime of what a footprint of a battery should be, and then invest in the idea of, we don't want to be replacing batteries every few years, because that doesn't necessarily solve our problem of having something that's supposed to invest in a long-term effect on a climate as opposed to the short term. And I think we're getting there, obviously, because this is all kind of new for a lot of people, but it's really like a lifetime thing. It's not investing in a miracle technology. It's like, if this thing is going to make a significant impact on its footprint or climate tech, then it needs to do so for a long period of time. And if not, we need to think about what the alternatives are.
Yeah, that makes sense. I think that I guess it is fascinating. We are learning. We're constantly learning. I think that the biggest issue is going to be trying to overcome this. It's a human issue, obviously, of just like thinking that we've got it figured out. We have to always remember that there's like blind spots, and constantly ask ourselves, where are the areas that we don't know? I'm also curious to see, again, this is maybe for a different podcast, but I'm always curious to see how government will hopefully become a little bit more agile, because you think about the regulations have a massive effect on the way the world turns out, right? So if there's if there's data that's tracking like how are things actually turning out compared to what we wanted to turn out, like maybe we'll change that real quickly as we go along, right? But that's another topic. But anyways, I really appreciate you coming on, Charlie. This has been great. Any final thoughts that you wanted to offer, or anything before we wrap it up?
Yeah. Thanks for having me. I think it's a really exciting time, and at ZapBatt we have a really exciting product that's going to come out this year, and I put my name behind it. And on the climate side, I hope that people can kind of do whatever they can to make an impact. I always like to tell people that both from the battery side and like the impact side, I've been on like the edge of sea ice, next to polar bears, putting battery solutions where in some of the most extreme environments, kind of seeing what the real climate impact looks like. And so I hope people want to learn more about what batteries can do for us. And I'm happy to, if anyone wants to reach out, do a deep dive into like battery 101, or always come to our lab and check everything out.
Absolutely. I sure hope people do take advantage of that. It's so great to have access. So thanks so much again. And we'll see you next time. We'll have to have you on again as you guys continue to develop things, and as new technologies come out. As I tell everybody, we'll have them on again. It might be a year or so, but we'll try to get you back on.
No problem. That sounds great.
All right, everybody. I really hope you enjoyed today's episode with Charlie. Again, to me, super fascinating technology, what they're working on, just generally speaking. Really was really excited to share this conversation with you guys today. So I hope you enjoyed it. Please do, if you're new here especially, subscribe and turn on notifications so you can be made aware of future podcasts and future conversations. And of course, if you're listening on Apple Podcasts, we do ask, please do rate and review the show so that we can continue to get greater reach. It really, really does help, and we really mean that a lot. Please also, of course, consider reaching out to Charlie on LinkedIn, connect with him on LinkedIn, learn more about ZapBatt in general. I think there's probably a good number of people that listening to this know either directly need this or could use this technology, or at least know somebody who might be interested in exploring these battery technologies with their own hardwares. So I think reach out to Charlie, connect with them, learn more. Please do, of course, consider joining the Slack channel if you want to get more involved with other professionals in the space. Maybe looking to make a job change, want to just chat about topics, feel free to reach out there. You can also subscribe to the newsletter, which comes out every month, discussing some of these topics in detail. And then, of course, you can reach me on Twitter with any questions you have. So a quick, teaser for next week. Next week we have we're going to be releasing 2 episodes. Both focused on hydrogen in transportation. So one company we talked to focused on the fuel cell itself, and then one on the storage of the hydrogen in these vehicles. So really fascinating stuff, something that I've not had on the podcast before. I think there's a lot of debate. I mean, I've gotten roped into so many of these debates on Twitter about hydrogen versus electric vehicles. And I think it's a fascinating conversation, right? So we talk to the experts; they know what they're talking about, and there's some really interesting things they're looking at. So tune in next week. Again, we will have 2 episodes dropping next week, both on the topic of hydrogen in transportation. So I'm very excited for that. But again, thank you guys so much for listening, and we will see you next time.